And we design our system so that it tries to minimize this error, right? But our system is constant, right? Or like a system, like we cannot change it, right? So what we do, we just like add a controller. Let's call this G of C of S. This is like the controller that based on the error value that you have, based on the deviation from the reference output, it would provide the correct input to your plant. So instead of having just a system like this that takes U and Y, now like what we have here, like we're gonna have a variable input to our plant. And where does this variable input come from? Comes from a controller that senses the error and provides the modified input to our plant, right? So this is the concept of feedback that we have. So that's why like we have two systems. One system is basically the controller, that its job is to take error and provide modified input to our plant. Okay. Now, this transfer function GP of S is basically this output in the S domain divided by U of S, right? Now that we have added many different components to it, the transfer function of this system, it's gonna be totally different from this transfer function, because this system now it's part of a bigger system, right? So now we want to find the transfer function of this closed loop system. Okay, so here we have one system that we have its transfer function. It's going to be y divided by u. We also have the transfer function of the controller because we design it. There are many different controllers. This one gives us the ratio between u of s and what? The input to this controller, which is, let's call it E of s, capital E. Okay? And what is E? And E is basically y ref of s minus y of s. Okay, everything is in frequency domain, in s domain. So let me actually, we did this before, it's a review, but it's an important concept, so let's just like do it one more time. So I want to find like y of s. And we said that y of s is equal to u of s times gp of s. And u of s itself, it's e of s times gc of s. Right? From here. So we have another gp of s here. Okay? And e of s is y ref minus y, so it's basically y ref of s minus y of s times gc of s times gp of s. Okay, the closed loop transfer function that we want to find, it's, let's call it T of S. It's something that relates the output to our input. Our output is y, our input is y ref. So it's going to be y of s divided by y ref of s. Okay, so I actually have a relationship between y and y ref. I just need to simplify this. So if I factor out ys, there's a 1 here, 1 and I'll take this one to the other side, 1 plus GCGP. I'm just gonna ignore the s's here. You guys like keep in mind that these are all in S domain. GCGP, I took this one there, and is equal to y ref times GCGP. And I want to find y over y ref. Y over y ref, it's gonna be, so that the transfer function, let me just like remove this, erase this, sorry. The transfer function, can you guys see the whole thing? Yes, just like adjust it a little bit. The transfer function, T of S, it's gonna be y over y of S